Good morning. Let me make sure everything's lined up. Move this a little bit. All right. Today we are going to continue on with some notes, and I think we're just gonna do one section, or at least I'll do one section in the video, and we're going to be doing. Well, we got to put our name and all of our stuff on top of our notes first. I always like to forget that. I'll start with Mr. Dan. It's 9/30. 2016. We are doing notes on 2.16. And 2.16 is scientific notation. Scientific notation. Now, the purpose of scientific notation comes about from a couple places. First, most numbers that we use in science don't necessarily come out as nice as the numbers as we've been using. We've been using numbers like 12 and 4, and when we divide these numbers, oh, it's beautiful, and it turns out as 3, so nice. But when we start doing actual math and going to the harder sciences, nothing really works out as well. And you're typically not dealing with just 3 and 4 of things. You're often dealing with huge numbers or very small numbers. And it can get quite exhausting to write those numbers. For example, if I'm going to write the weight of the Earth in pounds, I would have to write it like this. I would write it like this. Weight. Now, as you can probably imagine, the Earth is fairly heavy. Remember, LBS is our abbreviation for pounds. It would go like this. Good. And if I had to do every time I was doing a calculation, I had to first write this out like this on my paper before I could even start, it would be impossible. It would take forever to do any real math. So, what scientists do is they created a shorthand, a way to write these numbers that is much easier. Oh, let me show you one more example. If I was going to look at the diameter, which, remember, the diameter, if I'm drawing a circle, the diameter is right here. It's from one side to the other if I draw a line across its longest point. The diameter of an insect's cell. Diameter is about, sorry, let me count some zeros on here. Pretty small, right? So the idea of scientific notation goes like this. If I'm going to turn my weight of the Earth into scientific notation, I can write it instead like this. Or if I'm going to write my diameter of the insect cell, I can write it like this. And these are much more pleasant to work with than those. They are by no means wonderful and super comfortable to work with, but they are much, much easier to do than the ones above, which is nice. As a mathematician, I'm sure you guys are sick and tired of hearing me say this, but as a mathematician, I'm lazy, and I always try to do the easiest thing that I possibly can. Okay, let's look at how we turn a large number into scientific notation. Alright, first, we have, looks like we've got some 3 steps. First, we're going to move the decimal point so that it's to the right of the first non-zero number. And you can see that that happened here. The weight of the Earth, the decimal point is right here. I'll draw a little arrow. Right after the 1, which is the first non-zero number. Here's my number up here, my giant number. And I would move my decimal point all the way back here, because that's where it is, all the way up into the beginning. And that's kind of where I would do all my little hops, and I would count. I don't have to draw that out because that would take forever. But I can just count my total number of zeros and stick it all the way up in the very beginning. Same with here, but instead of moving it this way, I'm moving it this way. So I would move it all the way down to put my decimal point here, because this one already has it when I'm starting off, which is kind of nice. Okay, so that's our first step, but we're not done because we also have to add in those zeros another way that makes it easier for us to write. Okay, so then we have to count how many spaces. Oops, let me check. Count the number of spaces I moved it. Spaces. If I move the decimal to the left, it's going to be positive. If I move right, if I start here and go this way, it's negative, obviously. So the only other thing it could be, I guess, or maybe 0, right? Okay, now that I've done that, I need to put my number back in using that times 10 part. So the number I moved, the number of digits I moved, the decimal point, number of becomes my exponent. Okay, kind of. Okay, let's see. Let's take a couple and turn these into scientific notation. Now, some of you have probably done these before. That's okay. I still want you to stick with me for a couple examples. Okay, I'm going to put my rules up here so that we can kind of see them and check them out as we're going. Let's see if I can get that set up correctly. Looks like I can. All right. Let's start and look at example 1. We're going to take, what is this? 100,000 million. We're going to take 595 million. And we're going to turn it into scientific notation. Okay, first thing, my first step, move the decimal point so it's right after the first non-zero number. Okay, so I'm going to put it like this, 5.95. And remember, I can ditch all my zeros because now I don't need those anymore. But I'm not done yet because these numbers are vastly different. So they're not equal, so I have a couple more steps I need to do. Okay, so then I need, count the number of spaces I moved. If I move to the left, it's positive, right is negative. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I moved 8 spaces, and I moved to the left, so it is positive. Then I'm going to put my times 10 to the 8th. Oh, that wasn't so bad. Let's take a look at another one. Example 2. I'll make sure and see if you guys can see this. Yep, you can. Okay, cool. All right. Looks like the average distance from the Earth to the Sun is 1.48 times 10 to the 8th kilometers. What does that look like in regular numbers? Okay, so to do that, we would take 148, and I've got my decimal point right here, so I'm going to start moving it. And I have to move it 8 places to the right to undo it, right? So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So do you see how I had to move it starting here? So I counted those first 2 digits that I have, because they are part of what I'm doing. Now I can go back in and add my commas so I can see it a little easier. Hundred, thousands, millions. 148 million kilometers is the average distance from the Earth to the Sun. That's pretty far. Farther than I can comprehend, for sure. Okay, if you feel like you understand it from this point, go ahead. I'm going to do a couple more examples if you'd like to finish off the notes with me. All right. We're going to write... We're going to take another number and we're going to turn it into non-scientific notation. Let me see if I can get it all up here. Oops. Probably not. That's okay. We'll just pull in the notes and we'll see if we can figure out these without maybe looking at our own notes to the side so we can check it out and see if we can get the right answers. Okay, let's look at example 3. We're going to do this again. We're going to take a number and we're going to turn it away from scientific notation. So we have 4.5 times 10 to the negative 6th. So that means I'm moving the other way. I'm not going to add zeros on my normal way. Oops. I'm going to need to move this direction because it's negative. So if it starts here, I have to count 6 places that way. 1, 2, 3, 4, 5, 6. And I can put my decimal point right there. So I have 0.00000045. This number is very small. When you see a negative like that, it's going to be very small. When you see a positive number like this, that number is going to be huge. Those are one big clue that we can see. Because when we multiply by a negative like that, we are making this number incredibly, incredibly small. We are going to go way into decimals to get that correct. Alright, we're going to write this in scientific notation. We have 450 million. Alright, first thing, I'm going to put my decimal point right in between, or right after the first non-zero digit, right up in here. So I've got it there, so I need to figure out how many places that was. And I'm going left, so that means, well, let's look at our rules. If I'm going left, if I go left, it's positive. Okay, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, times 10 to the 8th. Nice. Easy. Let's see. Let's do one more. We're going to do 0.000000000067. And we're going to take this and we're going to turn it into scientific notation. So I'm going to start off by writing 6.7 because these are my first two. This 6 is my first non-zero digit that I have. And then I need to start counting and see how far this one's supposed to go over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Went 10 and it went to the right. And if I go to the right, it's negative. So that means I am going to go times 10 to the negative 10th. And notice again, this is much easier than I was doing before. And this clue is going to tell me that it's going to be small. And my original number was, so I should be good. Today, for the homework, is going to be pretty simple. You're just rewriting numbers from scientific notation, to scientific notation, and back again. Nice.